Asecos and the title Silent Dangers, Hidden Hazards on the Shelf. Before we begin, I'd like to briefly introduce myself. My name is Eva Albertsson, and I am a commercial communication specialist at Fisher Scientific. This webinar is part of a series of 5 webinars organized for the Environment, Health and Safety Week. These sessions are designed to raise safety awareness and help you better understand how to protect yourself and your work environment at Thermo Fisher Scientific. There are still 2 more webinars coming up this week, and you can still register for them. Please note, this webinar is being recorded. The recording will be shared with you after the session. Now, I'd like to hand over to my colleague, Isabel, who will explain how the Q&A session will work. So over to you, Isabel.
Hello, everyone, and welcome again to today's webinar. My name is Isabel, and I will guide you through the Q&A session after the presentation. You are welcome to ask any questions at any time during the webinar. To do so, simply type your questions in the chat box on the right-hand side of your screen, and our expert will do their best to answer your questions during the Q&A session at the end. Now I hand over to you, if I can.
Yeah, thank you, Isabel. So I think we are ready to start the webinar. So today we are joined by Dominique Reuter from Asecos. Dominique compiled a profound expert knowledge in the field of chemical handling and storage. For almost 2 decades, he is with Asecos GmbH, the world's leading manufacturer of fire-rated safety storage cabinets. Furthermore, Dominique established a global Asecos Academy training seminar in the field of occupational health and safety. Yeah, thank you. With his experience of more than 800 lectures in countries all over the globe, he contributed to a raise of awareness for chemical safety in general. I now hand over to you, Dominique. I wish you all an interesting and informative webinar.
Thank you very much. Okay, a very good morning to all of you. Yeah, as it was already introduced, I really hope that I could make use of this pretty much half an hour to sharpen your awareness when it comes to the active work and the safe storage of chemicals. Today, quite a focus will be on flammable liquids, since there is many different chemicals with different characteristics, but we can say the damage that is after a fire or explosion is extraordinary high. So therefore, focus on flammables. So I would like to share my screen with you. This should be visible for you. Yeah, and let's kick it off. Today it is about the silent dangers, the hidden hazards on the shelf. So before we look into the world of chemicals and which dangers may arise from those, a very short introduction of Asecos. So here is our headquarters. It's located half an hour car drive from Frankfurt am Main. So if you ever come to Frankfurt on a business travel, this is a standing invitation. We'll pick you up and in 30 minutes can visit our production site. What it stands for, Asecos, it stands for Approved Safety and Ecology Solutions. So we are strongly specialized in indoor storage cabinets for flammables, for all type of chemicals. We have, that is the only production side of Asecos, but we have sales and service centers like subsidiaries in the Netherlands, in France, in Spain, the UK, Switzerland, Sweden, and the United States of America. So if there should be some guidance necessary, required, one of my colleagues can always also visit you at your site and look into your chemical storage. And then can run you through our product line, our solutions, not only for flammables, for gas bottles, for corrosives, let's say for every chemical that poses any danger to your lab. And exactly that was the idea of our two founders, Günther and Michael. Back in '94, they made the vision come true to develop, to engineer the first 90-minute fireproof cabinet for indoor chemical storage. And yeah, I think we can say that we shaped the world of chemical storage indoors to quite some extent. But first off, maybe a little definition, what is hazardous material? Quite simple. So it is any item or agent, can be biological, chemical, physical, that has the potential to cause harm to human beings, to the environment. Those can be raw materials. Let's take crude oil as an example. So as we know, one drop of crude oil can pollute up to 800 liters of soil water. It can be products generated out of the raw material, let's say gasoline or diesel, and it can be waste materials. And this is oftentimes an issue if we visit companies. So the handling of waste material is oftentimes not as good, not as safe as the freshly bought chemicals. Then they go into a storage. They are still, of course, marked, labeled. Everything knows this is a hazardous material, but then the waste materials oftentimes are collected in just one bin, one container, without any symbol, any description. So people that don't know that just come by, they don't see actively this is chemicals. There is hazards inside this container, and this can lead to accidents, obviously. So certainly the characteristics are important. So this is a must know for everyone who's working with chemicals. And luckily we live in 25. So we live in the world of the GHS or REACH system. The GHS, the globally harmonized system for a worldwide simplified first administration, registration of chemicals, and labeling. So on that slide, you see the 9 distinct symbols that are given with the CLP or GHS system. So this has to be the same system used worldwide. So now we bought the chemicals, where to store them. There is, of course, several options available. So you could possibly, if you have a lot of chemicals at your factory, look for an outdoor storage solution. So like on that picture, you see a 90-minute fireproof container. It comes with all safety devices like an automatic door that would close if fire, if heat or smoke is detected. It comes with 90-minute insulation. So if a fire breaks out inside or outside, so either way is strongly protected against the effect of the fire. It has an integrated bottom collecting sump. So those chemicals, they cannot that easily run out of the storage, find their way to the soil water and pollute it. It's super safe, But what is the negative side of it? It's outside on the yard, so far away from your working place. That forces people to go waste back and forth, take the chemicals out to the workplace and then bring it back. And this obviously not everyone would do. Why take the chemicals back? I will need them next morning anyway. So then you collect more and more danger sources inside the facility. Similar, it would come with a central storage room, like a room inside a building. That is kind of more difficult compared to an outside container. First off, you have to look at the whole integrity of the whole installation. If you buy a container, you get all the certification, all what you need from the supplier. Just go for a well-known supplier that has all the relevant certificates he will supply you with. But if you plan to build a storage room, who takes care of the fire integrity of the whole installation? Is it the architect? Is it the construction company? Or is it, at the end of the day, the poor guys from EHS that sign the letter of integrity? And also, same here, one central room that supplies several levels of laboratories, not super flexible. So, and this then leads oftentimes to the users take the flexibility given, and the chemicals are just stored inside the laboratory. Yeah, there's a lot of work benches, bench spaces given. There is some rack systems. You have the best access to all chemicals. Perfect. Yeah. But there is no real shelter against the fire. Even the lab is ventilated with a certain airflow per hour. Still, there would be a chemical load in the workroom, in the laboratory. I guess not in the next picture. Here we have a super ventilation. This is a fume hood. A fume hood, of course, it is designed and given for active work with chemicals. It should not be misused as a storage, but exactly this is happening in that picture over here. It's very tidy, so you see all chemicals, perfect access. You still have some little space for the scale to work with, but that is, of course, not a right place to work in. And I could imagine after the shift is over or working day is ended, it is switched off, then also the ventilation would not work and the chemicals stay there unsheltered from any possible fire event. And it happens. It happens maybe not every day, but somewhere in the world it might be a scenario as such. Not worked according to all safety protocols, improper storage or handling of chemicals leading to burning down of the lab. So I just collected some examples from past 10 years, accidents that happened in Europe lately. Starting 2011 at the University of Southampton, a researcher was injured there due to improper handling of highly reactive chemicals. 2014, the ETH in Zurich, explosion involving flammable gases. Also there, a researcher was injured. Karolinska, 26, then mishandling of chemicals. And if you go further down the line, like University of Leiden in the Netherlands, no person obviously was injured, but extensive damage to facility due to a fire caused by improper handling of flammable chemicals. So it is happening, but the best part of it, we can protect ourselves. We can do precautionary measures to prevent such an incident. What I believe is very useful, we first should understand the nature of a fire. What is necessary, how a fire can come to happen in first place. Very well, it can be explained using this triangular shape. So we will build now the fire triangle. So a fire always needs three basic requirements at the same time, at the same place. Obviously, first of all, it needs a flammable substance. So if you think maybe even inside your laboratory or workspace, what flammable materials are there? There may be flammable gases, like hydrogen, for instance, or some solvents or other flammable liquids, but it obviously can also be solid material. Everything we can burn also back home, up the chimney, wooden material, paper, cardboard, that is all potentially flammable. A fire would not happen in a vacuum. So a fire always needs oxygen. So what is the oxygen concentration in our ambient air, the air we breathe? Right, pretty much exactly 21%. The oxygen concentration has a strong effect on fires. If, for example, you have a compressed gas, compressed oxygen tank that leaks, the concentration must only grow by 2%, not 21, but 23. And a fire would develop, would speed already at twice the speed. The speed of fire is doubling with just 2% of a higher oxygen concentration. Of course, also we human beings, we would not be too fit and effective in a vacuum, so we cannot really eliminate the oxygen. We just need it. So maybe we could substitute the flammable substance to a non-flammable one, but maybe also that is not possible. So what else does a fire or an explosion require to happen? Of course, it then needs any potential ignition source. So those three requirements, same time, same place, fire or maybe an explosion could happen. Potential ignition sources, here I limit myself to the main sources that the most often lead to a fire or an explosion. They are the open flame, like a Bunsen burner, or a mechanical spark that could be any metal body, metal tool that falls to the floor, creating a small spark. Or if we go away from laboratory application into the industrial world, when there is metal processing companies taking a grinding saw, they create lots and lots of mechanical sparks. Electrical sparks we find a lot even in office with all the laptop computers, mobile phones, other electric devices, the power plugs, the power sockets. If you do it in the night, or if you switch off the light and you pull a plug in and out, you can also visibly, you see that spark that potentially could ignite a flammable atmosphere. It could be a chemical reaction. Just as an example, mixing solvents and acids is never a too good idea. They pretty much have the tendency to chemically react, and then turn into a chemical mixture that is developing high heat, can cause the fire also. Exothermal reaction then. Electrostatic discharge, this may be one of the most neglected potential ignition source, bearing in mind that also us human beings can potentially discharge, or first charge and then discharge ourselves. Guess you all know what I mean. It best works in winter times or autumn times when there is a dry humidity in the air. You just have to, if you have non-isolating boots, you just walk over a carpet, or you put a woolen pullover on it without even realizing that you build up a charging. You first will realize when you go and get a hold of a grounded body. Most often it's a handlebar. Then you get this small impact, this small discharging. And there have been experiments that were proven that even this comparably small discharging caused by human being can be enough to ignite an explosive like a gas atmosphere. So especially if we work in explosive zones where there could be explosive atmosphere, we must make sure that we wear the right clothing, ESD clothing, so we cannot charge and discharge ourselves. And last but not least, the hot surface, any hot plate or hot body that could cause a fire. So I give you one example for an accident that happened during this, due to discharging that happened when pumping flammable liquids. So you please look just at this gentleman over here. So he is using this snorkel to pump in one flammable liquid from one tank to another one. So there was no grounding wire. So there was no possibility for the charging to be connected to an earthing point. It just built it up. It built it up. And of course, due to the liquids, the flammable liquids, they had their fumes, their flammable fumes. And due to this discharging, they ignited. And we will see, maybe already at this time, this building over there is lost. One brave gentleman tries to use a handheld extinguisher, but there's no chance to get even close enough to the source of the fire, too much radiation of heat. So really no chance. Now, with so many liquids being on fire, also a sprinkler system would not be effective enough. The fire just spreads from one cubic tank to another one. Due to the toxic smoke, the building, the room is into darkness by the toxic fumes that are emitted. And really the building is lost. So the only thing maybe possible for the fire brigade, stay outside the building. If there is connected buildings, try to cool the burning building or cool the neighboring building to at least not make the fire spread from the burning to another building. But that's the maximum that still can be accomplished at this point. So it is important for everyone dealing with flammable liquids to know a little bit more about them. I will now just let the video play. It's lost anyway. Dealing with flammable liquids, you should be aware that according to the GHS system, there is 3 classifications: GHS category 1, 2, and 3. They are then classified according to their flash point. On one hand side, we have the highly and extremely flammable liquids. There, the flash point is less than 23 degrees Celsius. If then boiling temperature is less than 35 degrees Celsius, those liquids will be extremely, if it's more than 35 degrees, highly flammables. And we have the GHS category 3, that is flammables with a flash point between 23 degrees and 60 degrees Celsius. Yeah, flash point, I didn't mention it yet. Flash point, that means the lowest temperature at which enough vapors are emitted by the liquid, so they form a ignitable mixture in contact with air. Yeah. So, but then at this stage, at this temperature, it would need a additional ignition source, so this ignitable mixture can be ignited. I would like to give you 2 examples of 2 liquids with different flash points, or Stefan, my co-worker, will do it. First of all, gasoline, petrol. Extremely flammable substance, flash point somewhere minus 20 degrees Celsius. So even on deepest winter days, if you have an open container of petrol, of gasoline, fumes will be released. And all it requires to turn them into a fire is an ignition source. So that was pretty simple due to the high flash point of the petrol. Now this one is a little bit more difficult. Paraffin oil. According to the mixture, it has a wide range of potential flash points, somewhere between 35 degrees, maybe even over 60 degrees Celsius. So that means under normal room temperature conditions, paraffin oil will not burn due to missing fumes or vapors. But yeah, we will simulate the situation. That could also happen naturally if you have an open container of a substance, of a liquid with a flash point around 30 degrees Celsius. You put it on a summer day next to a window, direct sunlight is going onto it, and then over the day the temperature grows, and at a certain time or certain temperature, then we will see that the separate ignition source then also ignites the paraffin oil. So therefore, really my big recommendation would be, don't make a difference. Either whether you deal with extremely highly or just flammable substances, all chemicals, all containers that carry this pictogram, handle them safely, be aware of the fire triangle to keep ignition sources away from that substances. When it comes to storage, please look for a fireproof area where you can store them, since at a certain temperature they will make no differences. They all burn pretty much the same. Giving you some examples of the different flammables with different flash points. Here also indicating the auto-ignition point. That's also very important. Auto-ignition temperature is the lowest temperature at which those solvents spontaneously ignite. Just by getting heated, warmed up to a certain temperature, they don't need a separate ignition source. They are ignited by reaching the auto-ignition temperature. And I find it interesting. Paraffin oil, that has way the highest flash points of all these chemicals, has at the same time the lowest auto-ignition temperature. So there is really no direct correlation saying a low flash point automatically says a small auto-ignition temperature. It's different from chemical to chemical. So methanol, flash point also way below room temperature, auto ignition temperature around 380 degrees Celsius. So I hope you had a good breakfast already today, because I find it a little bit hard to digest the story around that picture over here. Here you see the picture after a methanol fire. If you find yourself in a place, in a laboratory where you have that many flammables and chemicals around, so either you clean it up or you look for another job, because this is a very dangerous working place. What has happened? We don't know exactly how the methanol caught a fire, so most likely it was a hot surface. But one fact about a methanol fire, the flames are invisible. So this gentleman that died at this place, he didn't see it coming. He was in the middle of a fire without really seeing it with his eyes. There were no flames. So of course he realized, due to the strong heat, that he was burning in a fire, but there was no way to rescue him. So what we see over here are the remainings of his working clothes, and what we else see, it is fat and body liquids. So this gentleman died at this place in a methanol fire. So I was talking about fires, flammability. What is another thing that should very well be considered? It is the fact that flammable liquids can also explode due to the right mixing ratio. So again, it is Stefan to show you a little bit about it. It is straightforward, small experiment using petrol, drop-wise now. Stefan will bring it into this half-liter bottle, shake it a little bit to get these drops vaporized. And then, if you remember the fire triangle, he will move in with a potential ignition source. So that first bottle, it is quite a homeopathic dose, just using one single drop. That is the ignition source. Nothing really happened. So we can assume that one single drop on half a liter room volume is not turning into an ignitable mixture. Have you heard of Paracelsus? The dose makes the thing a poison. So let's use a different dose. That was 5 drops now. That was quite different. So we learned 5 drops of a flammable solvent on half a liter room volume turns into an ignitable half-liter mixture. Now we could think more will also help more. We will not count the drops, but use straightforward 2 milliliters, maybe 60 drops. Assuming that the explosion now will be even more violent. But this is not the case. So here comes the explanation. With the first bottle, one single drop on half a liter, we've been in the area less than the lower explosion limit, somewhere over here. LEL, lower explosion limit, no explosive atmosphere will happen. Then the 5 drops where this small explosion happened, we have been in the dangerous area. That will mean between the LEL, the lower explosion limit, and the UEL, upper explosion limit. So in that range, we will always find an explosive atmosphere. Then 10, 15, 20 drops is already turning into a rich mixture, being beyond, above the UAL. Then again, it will not be explosive, this mixture. It will be too rich, too saturated. You saw this, like candle burning. That again happened due to dilution, entering air oxygen that made the mixture around the bottleneck flammable but non-explosive. So 5 drops we saw in the video turns into half liter, 500 ml explosive atmosphere. Then if we do the mathematics a little bit further, we come to the conclusion that just a shot glass of 20 milliliters on a 200 liter scale drum will do the job. I mean, don't do it back home, but it's a fact. 20 milliliters, they vaporize into 200 liter explosive atmosphere. And I always find it shocking, that fact that 1 single liter, these handheld amounts that you find dozens in each and every lab, if just 1 single liter would vaporize. I mean, take diethyl ether as an example with very high steam pressure. It will quickly turn into 50, 200 liter drums. So nicely, there will be 10,000 of liters of explosive atmosphere in your work environment. That is just not acceptable. So therefore, of course, there is possibilities to prevent from such a scenario. If you use a fireproof cabinet, that should be ventilated. Technical ventilation, of course, takes away the fumes, the vapors, and there minimizes the risks of explosive atmosphere. How that works with a Asecos cabinet, the fresh air comes at the top section, and then most efficiently is a diagonal airstream. That means the air goes to the other side diagonally. There it is captured by the exhaust opening, and then it is transported towards the blower on the roof of the building, or you can use a recirculating air filter working with active carbon that gives the fresh, non-harmful air back to your room. And it is of quite a reason why the exhaust should be at the bottom area. So I will show you why. Again, I will take petrol. Romantic atmosphere. So I will light a candle for you. Just some drops of petrol on this cotton batch. Wait for some seconds. And the fire is there. So there were no liquids running down that slope. Again, what we saw here have been the vapors. And my very point at this stage is all vapors that are released by flammable liquids are heavier than air. If you work in a laboratory using solvents or use washing petrol back home for cleaning metal surface, please be aware those fumes, they will collect at the working desk, or maybe they will even go down to the earth level and then accumulate and build up. So straight at the place of work, there is the dangerous area. There is the fumes that only wait for a potential ignition source to catch fire, which we want to prevent, obviously. Those key points, they shall always be considered to prevent from explosion or from fires. First would be the auto-ignition points to not be reached. This you can do by a certain fire resistance of the storage room or the storage cabinets you're using. And to keep the mixtures lean, to prevent from an explosion, they should be technically ventilated. As I said, there was or is a strong focus on flammability today, but of course, in every laboratory, we will see not only solvents and flammables, you would also find maybe toxic substances or CMR substances, cancerogenic, mutagenic, reproductionary toxic. And we need to make sure which way those chemicals enter our body. Do we breathe them in? The gases, the vapors, dust, aerosols, or if it's liquids, they might be swallowed, taken by mouth. Oftentimes, it's also then the cutaneous absorption, if your skin would uptake the chemicals. And then different chemicals, they target different organs, like solvents. Oftentimes, it's the brain, or methanol especially is targeting the eye. So oftentimes it happens when there is a moonshine party, people get blind or even intoxicated and dying from high methanol concentration. So my very point is, ventilation is important, not only to prevent flammable areas or explosive, it is most important to prevent intoxication of ourselves, of you, of your co-workers. So when there is chemicals, a proper ventilation is necessary. It's not a nice to have, it is definitely a must. Like in that case, customer certainly invested a good sum of money to get top of the notch fume hoods installed. So that really means in that area over here, we have a permanent airflow. So no fumes could really collect over there. It's a very safe place to work. But what we see underneath, it's quite critical. All these bottles, they are open, screwed open. Here is a funnel, so you can just dispose your chemicals. I can imagine there's quite a smell that is emitted by those open containers. So it would be much better to make use of the space underneath of the fume hood for some proper storage devices. Maybe nothing like that. That one over here, it's not a real safety storage cabinet. It's just a single skin metal construction painted yellow with a warning pictogram. That's it. On the next page, we will see insulation is very little. We can say it's no insulation. It comes without any certification, so no fire resistant. Disaster risk is definitely high for people that are responsible for this area. The legal consequences, they can also be very devastating. In United States and other parts of the world, those type of cabinets is state of the art according to the FM 6050 standard. That means double skin metal construction with some air insulation in the middle. Tested for 10 minutes. So maybe a medium low safety is given with such a cabinet. In the European safety thinking and also the norms, we speak about at least 30 minutes as the minimum of evacuation time or fire resistant time, and we have 90 minutes as state of the art. Usually it should not be less than 90 minutes. And if you ever think of a proper installation, a proper safety storage, have a look at this norm, the EN 14470 part 1. This is always state of the art. Maybe it becomes a little bit more obvious looking at this video. So we went to Finland to test the different storage cabinets which are available. Like to the left-hand side, the single skin metal, in the middle, the FM 6050 American, to the right-hand side, 90 minutes. So, and this is really what you get investing into a proper 90-minute fireproof cabinet. It gives you time. It gives you up to 1.5 hours of evacuation time for the people to get evacuated from the building, and giving enough additional time for the fire brigade or entering the building, try to extinguish it. Yeah, sometimes it's a question, does it really take 90 minutes? Isn't 30 minutes good enough? It's really according to your risk assessment. But believe me, one thing, on the day a fire breaks out in a building, every second matters. So every additional minute that you have to leave the building for the fire brigades to enter is valuable. So it should not be a matter of money. Do I save any money taking 30 minutes instead of 90? It is really to protect your safety, your life essentially, and also the assets that are lying in your company. And then, yeah, like in a modern laboratory, those cabinets can be integrated right in the lab, right at your workplace. So you don't need an outside container or one central storage room. You can have your daily, weekly amount of chemicals straight at your laboratory. And I think that also eliminates the risks that are happening during transportation, like in-house transportation of chemicals. Okay, coming to the end of my session today. If you give me 1 more minute, I would like to draw some conclusions after my talk. First thing, you should really watch out for containers that carry GHS pictograms, those 9 pictograms that we saw. There is no clear threshold when a quantity of hazardous material becomes dangerous. Yeah, remember that 1 liter of a flammable liquid can turn into 10,000 of liter explosive atmosphere. Yeah, even the small amounts can be fatal. We cannot see explosive atmosphere, so yeah, we must find technical ways to eliminate the buildup of an atmosphere. So we need to shield it by proper fire insulated material, and we need to give it a strong technical ventilation. If you would like to keep up to the state of the art, really a storage cabinet with 90-minute fire protection according to the EN 14470 part 1 is that state of the art possibility you have. Okay, that's it from my end. I would like to give it back.
Thank you, Dominic. Yeah, we have some questions, so if we take a few minutes to answer them, we can start. Where do you find the relevant safety data sheets for the chemicals you are using?
Very good one. Of course, every vendor, every supplier, every manufacturer, he is forced by laws, by the CLP classification, labeling, packaging of chemicals to provide the safety data sheet. Yeah. Do we see can I put something in at the chat over here?
Yeah, sure.
Is this visible for everyone? Do you see what I just wrote? Guest this?
Yeah, guest this, yeah.
Guest this. So if you type it in any searching machine on the internet, this is the best data bank for safety data sheets. It's hosted by the property insurance company of the chemical department in Germany. They always have, also in different languages, at least in English, they always have state-of-the-art actual safety data sheets. That's a very, very good resource if you're in search of such a safety data sheet. Yeah.
Okay, Dominic, thanks. Next question, where do you store your flammables?
Do you mean where I store my flammables? No.
Well, is the question, it says, where do you store your flammables? Maybe it's a piece of advice that they are asking you.
Yeah, I mean, of course, yeah, we at Asecos, we sit on the source, so to speak. Yeah? So we are producing our cabinets enough that we even sell them, but logically we also need some in our factory lubricants, cleaning materials. So we store them. We production is organized in lines, several production lines, and each production line has at least one 90-minute fireproof storage cabinet. So they don't need to go long ways to take the chemical they needed. We also, I admit that, we have also outside storage that is 10 meters away from the building for the bulk quantities. But the daily amount of chemicals, they are very close to the working place.
Okay, thank you. And the last question is, how long will it take to evacuate the building you are working in?
Yeah, that is always a good question. I don't remember when it was last time, but regularly there is fire drills here at Asecos. The pleasant part about it, they are announced. So usually the evening before we get a email and a message that says, tomorrow 9:30 there is a fire drill. So you're absolutely prepared. So then when the signal starts, you go very silently, slowly down the stairs. Then you realize, oh, I forgot my iPhone, cigarettes, whatever. You go back to your office, take what you need. In less than 3 minutes, you're out of the building. That is when there is an announced fire drill. Luckily, I've never been into a real fire incident, but once it happened to me, I showed some videos here today when I and my colleague Stefan were doing some small experiments. One experiment I did with sulfuric acid. I had my gloves and goggles and everything, but it came to happen that one drop of sulfuric acid went on my upper lip. I first thought it was water, but then it started burning. So, and I panicked. I knew that I sometimes doing stupid things. So before we did this video and this experiment, I was looking where is the next safety shower. It was just 5 meters straight and then left. But then when it happened, my upper lip burning, I panicked. So maybe 5-10 minutes later, I found myself at the other side of the road in another factory of Asecos looking for a safety shower. So I can only really stress if there's a real fire. Also, the smoke will turn the whole building into darkness. It's not like bright light where you can see it. It's totally dark. And if you stay in such a toxic smoke environment, you don't have even 2 minutes. 2 minutes, otherwise you will faint. You will get intoxicated by the smoke. So you need to be out of a burning building really in less than 3 minutes. But then when you panic, you tend to take longer for such a scenario. So it is very important that no chemicals in that time also start burning, release toxic fumes. This would turn the whole thing into a horror scenario, really.
Yeah, good tips. Thank you, Dominic. And the last question came from David. Hi, Dominic. Thank you for a great presentation and for sharing with us the number of the examples and situations with increased risk for fire and explosions. Can we raise one most important situation for our PSG colleagues in the RSD lab and one in the production environment that they should definitely check following this webinar and make sure they are covered for fire and explosive risks?
Yeah. I mean, how shall we handle that case? I mean, what I, of course, can offer you, how about a joint tour through one of the sites? Can be me, can be one of my co-workers of Asecos. Shall we maybe together go inside your R&D lab and production site and check whether everything is up to date? I mean, it was also one of my last points. The first thing really should be go to your chemical store or where you think the chemicals are stored and look out for GHS pictograms. Basically, it's also covered by regulation. There must be a register, a chemical register. And look for that one. All the chemicals along with the relevant safety data sheet must be captured. And this one really is important for also the owner of the company, for the top managing. So if a fire happens or if any incident happens, the same day the insurance company will be on site. And not only them, I mean, if there is people injured, hurt, or even worse, it is also the police and the state's lawyer that come investigating. And that will be one of the first things to happen. They will ask, please, can you show me your chemical register? Can I look into the safety data sheets? Can I look into your recommendations, like work advices? What did you do to prevent the thing that happened? Without these written forms and regulation, it can become very nasty for a company owner if you don't have a proper risk assessment in place. That's usually the thing. We need to look into the risk assessment for chemical work and chemical storage. That is the key. And the proper risk assessment is really the key tool in all safety concerning points.
Okay, thank you, Dominic. I think that's all. We don't have any more questions. So hand over to you, Eva.
Yeah. Thank you very much for an informative webinar, very interesting, and that there are so many, dangerous things out there in the lab. So I think we all now are more aware about that. That was a great session, and I'm sure our audience appreciated it. A special thank you to you, Dominic, for your time and for sharing expertise with us today. And before we close, just a quick reminder, we still have 2 more webinars this week with Street and Brady. Make sure to register if you haven't done so already. So have a great afternoon, everyone, and until next time, goodbye for now.
Thank you. Bye-bye.
Thank you. Bye. Bye.